All right, so if you've ever tried to run a stateful application on Kubernetes, you know the deal. Persistent storage can be a real headache. Well, today we're going to demystify Longhorn, a super powerful open source solution that's designed to fix that exact problem. So, here's the game plan. We're going to start with why storage is such a challenge in Kubernetes in the first place. Then, we'll introduce Longhorn and get into its really cool architecture. After that, we'll dive into how it keeps your data safe with things like replicas, snapshots, and backups. And finally, we'll wrap it all up with why this thing is such a game changer. Okay, so let's kick things off with the big question. Why do we even need a tool like Longhorn? What's the problem we're actually trying to solve? Well, it all goes back to the very nature of Kubernetes and the kind of apps we want to run on it. If you've ever tried this, you know exactly what I'm talking about. Running a database, or maybe a message queue, on Kubernetes is a totally different ballgame than just running a simple web server. The main challenge? Well, the application's data has to stick around, even when the pods themselves come and go. And this slide just nails it, right? Kubernetes is an absolute champ with stateless apps. A pod dies? No problem, a new one just spins up to take its place. But for stateful apps, the data is literally everything. You've got to have a storage layer that doesn't care about the life cycle of any single pod. And this is exactly where Longhorn comes into the picture. It was built from the ground up to solve this very problem. It brings a truly cloud-native way of thinking to persistent storage, really aiming to make it just as easy to manage as our applications are. So, at its heart, Longhorn is what we call a distributed blocks storage system, made specifically for Kubernetes. And here's the genius of it. It takes the local storage you already have on your Kubernetes nodes and transforms it into this super resilient, replicated storage pool for your stateful apps. And best of all, it's completely open source. So what's the secret sauce? What makes Longhorn so good at what it does? Well, it boils down to a few key ideas. First, it's all based on microservices, and you'll see why that's so important in just a minute. Second, and this is my favorite part, every single storage volume gets its own dedicated controller. Total isolation. It's also thin provisioned, so you're not wasting disk space, and the whole thing is managed just like any other Kubernetes resource. Now, let's peel back the layers and see how this all actually works. Because the real magic of Longhorn, I think, is in its architecture. It's pretty elegant. The whole system is basically split in two. You've got the Longhorn Manager, which is the control plane. Think of it as the brain of the operation. It manages all the volumes and handles all the API calls. And then you have the Longhorn Engine. That's the data plane, the muscle that does the heavy lifting of actually reading and writing your data. And this slide puts it all together. The manager runs as a daemon set, which just means you have a copy running on every single one of your nodes. When your app asks for storage, using a standard persistent volume claim, the manager spins up a dedicated engine, or a controller, just for that volume. That engine then takes over and is responsible for writing all the data to multiple replicas spread across your cluster. It's pretty slick. And this quote right here from the docs, this is the most critical thing to understand about Longhorn's design. Because each volume has its own controller, if one of them fails, it has zero impact on any of your other volumes. This blast radius isolation, it's a huge, huge win for the stability of your whole system. All right, so we get the architecture now. Let's talk about how Longhorn actively protects your data. We'll start with the stuff that happens right inside the cluster, replicas and snapshots. So right out of the box, Longhorn is built for high availability. By default, it creates 3 separate copies, or replicas, of your volume's data, and it scatters them across different nodes in your cluster. What that means is your volume can actually survive the complete failure of 2 of your nodes, and you won't lose a single byte of data. Now, the next layer of protection you have is snapshots. Honestly, the easiest way to think about them is like hitting quick save in a video game. They're instant, point-in-time pictures of your volume. So if you accidentally delete some important data, you can just roll back to a previous snapshot in seconds. It's a lifesaver. But, and this is a really important but, snapshots live with your volume data inside the same cluster. They are absolutely fantastic for quick operational recovery, those oops moments, but they are not going to save you if your entire cluster goes down. For that level of protection, for true disaster recovery, we've got to get our data off-site. And that is exactly where Longhorn's backup feature comes into play. This slide makes the difference super clear. Snapshots are for your day-to-day in-cluster recovery from things like accidentally deleting a file. Backups are for recovering from a complete catastrophe by storing your data in a totally separate, remote place. So what a Longhorn backup does is actually pretty simple. It just takes one of those point-in-time snapshots and copies it to an external system, like an S3 bucket or an NFS share. And just like that, you've completely decoupled your data's survival from the health of your main cluster. And what's really clever is that this whole process is incredibly efficient. Backups are incremental. That means Longhorn only copies the data blocks that have actually changed since the last backup. This saves a ton of storage space and network bandwidth, which is what makes doing frequent backups totally practical. Okay, so let's pull all these threads together. We've talked about the problem, we've gone through the architecture, and we've covered the safety features. But so what? What does this all actually mean for you and your team on a daily basis? Here's the bottom line. Longhorn gives you enterprise-grade storage features, but in a simple open-source package. You get high availability because of replication, you get layered data protection with snapshots and backups, you get operational simplicity because you manage it just like any other Kubernetes resource, and of course, that killer feature, failure isolation, which makes the whole system incredibly resilient. And that really just leaves us with one final thought to chew on. With systems like Longhorn becoming so powerful, yet so simple, are we watching a major shift happen? Is this kind of reliable, application-focused storage becoming the new normal for everything rebuilt in the cloud? It's a pretty compelling question about where our infrastructure is headed.